All right, so section 3-1, we want to talk about line relationships. Line relationships. So first off is parallel lines. You guys already have experience with parallel lines. The issue here is that you got to make sure that you understand that parallel lines are coplanar. So they're lines that have to be in the same plane are then parallel lines, or can be parallel lines. Same plane and never intersect. Parallel lines. So we could have these guys right here, parallel lines, right? Parallel lines. Okay. So they have to be in the same plane. Unlike skew lines. Okay? Skew lines are lines that they're not considered parallel, but like parallel lines, they never intersect. Okay? Skew lines can look like that. They're in different planes. Okay? Skew lines are in different planes and also never intersect. So that's your difference. Parallel lines never intersect, but they're in the same plane. Skew lines never intersect, and they're in different planes. Okay? All right. And then last thing is parallel planes. You also need to know that planes can be parallel. Planes can be parallel. So for example, of parallel planes, think of the ceiling and the floor. The ceiling and the floor are parallel planes. Of course, they will never intersect, barring any catastrophe or earthquake. All right? So, that wall over there, the wall over here, parallel planes. They never intersect. It's still just hanging there. All right. So, planes can be parallel. Lines can be parallel. Lines could also be skew. Planes cannot be skew. Okay? Planes cannot be skew. Okay, because if they're skew, they're going to intersect somewhere. All right. Couple other things you want to need to know. Looking up here at the symbols for parallel lines. Those two lines going up and down, that is the symbol for parallel. I don't write it that way because a lot of times my handwriting gets sloppy and it starts to look like an 11 or maybe eyes or something like that. So I would go ahead and write that line AE is parallel to, so I still use the symbol, I just write it at a slant. Okay? Parallel to BF. All right? So that's how I'd write that. There's another symbol for parallel you need to be aware of, and that's over here on our diagram. So the two vertical red lines, line AE and line BF, they are parallel because they tell us that in the symbol portion of this. But there's another symbol. Right here in the middle of the lines, you see this little arrow. All right, I call them carets. Okay, so we have a couple of carets here. And just like we did with congruent segments, we use a little dash, right? Well, same thing here with parallel lines. There's one caret here, there's one caret there, so that's marking those two lines as parallel. Looking at the red lines on the top, line AD and line BC, those are marked with 2 carets. Okay, they're marked with 2 carets each, so therefore they're parallel to each other. Of course, they're marked differently than the lines going up and down, like line AE, showing you that they're not parallel to A and E, right? Or AE. So, there's another symbol for parallel that you need to understand or need to know. And the last thing I want to show you here while I have this diagram up is line AB and line CG, the blue lines. What are those examples of? Skew lines. Yes, they are not in the same plane and they will never intersect. Okay? And by the way, you need to make sure that you're understanding what you're looking at here. Because some people I've heard say, well, wait a minute, aren't these going to intersect if I bring this out all the way here? Aren't those going to intersect right there? Yeah, no, because this diagram is implying a three-dimensional shape. Right? It's implying a three-dimensional shape. And so those two lines, even though on the two-dimensional surface of your paper, you could draw those lines to intersect, but what it's representing is 3 dimensions, and they will never intersect. They are sitting away from each other. This one is sitting here. This one is sitting over here. So look at the actual lines themselves. Are those going to intersect my sticks? No. But do the shadows intersect? Yeah, because that's now projecting a two-dimensional picture, right? The actuality of what's going on, they don't intersect. Yeah?
Where it looks like it's intersecting, would that become a dotted line? Since it's in the back?
No, I just wouldn't draw it as intersecting. Or you'd have to just know from the diagram, knowing that this is in the front and that's in the back, that even if they draw it as intersecting, it's not actually intersecting.
Okay.
All right? Good question. Any other questions on skew versus parallel? Or the diagram? No. Let's take a look at an example then. And by the way, they do say here in your notes, a line and a plane that do not intersect are called parallel. Okay, even though lines and planes, they wouldn't be in the same plane. That's only two lines have to be in the same plane to be parallel. Okay? But lines and planes can be parallel as long as they never intersect. Okay? And segments and rays can also be parallel or skew. Since entire lines can be parallel or entire lines can be skew, therefore portions of those lines, like a line segment or a ray, can also be parallel or skew. All right. So looking at example A here. First off, the diagram of that box, they don't say it here, so we are going to be talking about line segments and things of that nature. But when they start talking about planes, they are implying the entire plane going on forever. In your homework, they give you a diagram like this, but they do actually start talking about entire lines. They can't draw the whole line, but they are saying, hey, the entire line AD, not just what you see line segment AD. So make sure you pay close attention to that and give your answers appropriately. Oh, and before I go any farther here, I don't know why they did it, but they named these planes wrong. Please cross out the last letter there. You do not ever name planes with 4 points. It is never okay to do that.
Is that the same for letter G? Both the letter G's, actually.
Yes, down in the example we're working, same thing. Cross out that last letter. You never ever name planes with 4 points.
Why not?
Because that's how we know to name planes. We name planes with 3 non-collinear points. Period. I have no idea why whoever wrote this book named it with 4 points. Okay? All right. So take a look at example A. In example A, we have, we want to name which line segments are parallel to line segment AB. So does everybody see where AB is located? AB right there. So what line segments are then parallel to line segments AB? Line segment EF, I 100% agree with that.
Line segments C.
EF, and you said, what was the other one? DC, I agree with that. DC, let's see, I heard GH, I agree with that. Thought I heard another one. Did I not hear another one? I thought I did.
Oh.
Well, I'm happy I didn't hear another one because actually those are the only 3. Okay? Because that is one thing they do say in the instructions. That's why it's important to read the instructions. It says, assume that lines and planes that appear to be parallel are parallel. Okay? They tell us to assume that. So therefore, we can say that line segment AB is parallel to line segment DC. Absolutely. Yes?
Okay, but that's really confusing because it's...
Okay, then let's take a look at example B. Which segments are skew to line segment CD? Now, line segment CD is right here. What would be skew to that?
BF.
Okay, hold on. BF, I agree. Yep, line segment BF.
AE.
Line segment AE, I agree with that.
EH.
Line segment GF, I would agree with that. Anything else? What? EH, I agree with that. Anything else that you're questioning whether it is or not? Why does DH not? Why is DH not skew? Because they intersect. They intersect. Same thing, you can't say that BC, line segment BC is skewed to DC because they intersect. Okay, skew lines are in different planes and never intersect. Why can't I say that line segment EF is skewed to DC? Because they're parallel. They're not skew, they're parallel. All right, very good. What are two pairs of parallel planes?
BAD and FEH.
Plane BAD and plane what?
BAD and FEH.
FEH, I agree. We need another set, another pair.
BAF and CDG.
BAF. Okay, one thing I'm going to ask you on naming BAF, and I know I haven't said this before, and so it's okay that you name it BAF. I strongly suggest when you name planes when they're given in diagrams like this, start at a point and then work your way around.
Yeah.
So I'd name it ABF. And the only reason I'm saying that is because that plane is in the shape of a rectangle. And when we start talking about rectangles and stuff in this class, we name polygons using that method where we start at a point and then go around the polygon.
It doesn't matter what point though, right?
Doesn't matter what point you start at. Okay, but the reason I'm saying that now is so that you get in the habit of doing that. Okay? No, it doesn't matter if you go clockwise or counterclockwise. It doesn't matter what point you start at. But just once you pick a point, just kind of go around it when it's a polygon like this.
So BAE and CD.
So BAE's work, and you said CDH. Yep, perfect. So plane BAE and plane CDH. Perfect. And of course, there is one more pair of planes that are parallel, right? We've named the top of the box and the bottom of the box. We've named the left and right sides of the box. We still have the front and back.
Yeah.
Okay? So you can name plane ADH and plane BCG are also parallel planes. All right. What two segments are parallel to plane BCG? BCG is the back of the box. So what two segments would be considered parallel? There's not more than two segments. There's actually four.
Segments or planes?
Segments are parallel to that plane. What do you think?
AD.
AD. Line segment AD, definitely.
AD.
EH, definitely. EH, AE. AE and DH, excellent. All those are correct answers. If there was a line segment AF, or I'm sorry, not AF, AH drawn, that would also be parallel to plane BCG. Because if you think of the bottom of the box down here, and say my iPad is the top of the box, you're not looking at me. Bottom of the box down here, my iPad is the top of the box. If this line segment is parallel to this entire plane, well, wouldn't this line segment also be parallel to that entire plane? Any line segment that's in this plane is parallel to this plane.
Oh. So you're saying like BCG would just be like BG going down? What?
Okay, then real quick, I would like everybody to do example A and B. Ready, set, go. Okay, looking at example A there, which segments are parallel to line segment AD? What do we think? Anybody tell me one? Line segment BC, I agree. What else? EH, I agree. EH and yep, FG. Please make sure you are using proper symbols to name these things. Okay, you cannot just put B and C and call it done. BC means the distance from point B to point C, whereas BC with the line or bar across the top is talking about the line segment. So make sure you're talking about the proper thing. Part B here. Explain why line segment FE and line segment CD are not skew. Because they're what? Because they are parallel. Okay, that's because they are parallel. And again, talking about that, why are they parallel? Because if I look at this segment and that segment, I can put a plane going diagonally through that box that connects those lines, or isn't there? Those lines or segments are in the same plane. Okay. Any questions there? Identifying parallel lines, skew lines, parallel planes. Beautiful. Go to on the back side, first off, we have another line to talk about. Another type of line to talk about, and that is the transversal. Okay? A transversal is a line that intersects two or more other coplanar lines. Okay, so a transversal and the lines it's intersecting all have to be in the same plane. So the same plane of your piece of paper, basically. Okay? And so then this line T is intersecting line L and line M, so therefore line T is a transversal. Okay? When you have a transversal intersecting pairs of lines, you then end up with 4 angles at one intersection, 4 angles at the second intersection, and so we end up with 8 total angles that we're going to talk about them, how they relate to each other. Okay? Another thing that you're going to have, line L and line M, between them, we call that the interior. Outside of them, we call that the exterior. That comes into when we name our angles, interior versus exterior. The interior portion is all this in gold, that is between our two lines being intersected. Exterior is then outside of that. All right. So let's take a look at our angle pairs then that we want to talk about. So again, we just have our diagram brought down here for us. And our first definition here is an alternate interior angle pair. Okay? So alternate interior angles. Alternate, they call it alternate because they're on alternate sides of the transversal. Okay? So for example, angles 4 and 6. Angle 4 is on the left side of the transversal. Angle 6 is on the right side of the transversal. They're called interior angles because they are in that interior portion between our two lines being intersected. Alternate interior angles. I also refer to them as Z angles. Okay? They're Z angles because a Z forms a pair of alternate interior angles. Just like angle 4 and angle 6. Okay? Now, angle 3 and angle 5 also form a Z, but it's backwards. Okay. So, alternate interior angles. That's what they look like. Same side interior angles. These, by the way, are sometimes referred to as consecutive interior angles. Consecutive interior angles means the same thing. I'm telling you the other vocab word for it because I have no idea if the state NISA exam is going to use consecutive interior angles or same-side interior angles. I have no idea if the ACT is going to use consecutive interior angles or same-side interior angles. So I want to make sure you're aware that this means the same thing as that. Okay? So, same-side interior angles or consecutive interior angles, I refer to these as C angles. Now, I want you to learn the vocab, so calling it a C angle is not okay for a test or a quiz, but it is a way for you to help you identify what these things are. Okay, the C angles, because a C, if you make a block C, of course, forms these sets of angles. So, like angle 3 and angle 6. They are on the same side of the transversal, and they are on the interior of lines M and L. So they're same side interior angles, just like angles 4 and angle 5 would be same side interior angles on the other side of the transversal. All right, then we have corresponding angles. Corresponding angles. You have to look at the individual intersections. So for example, if I look at just this top intersection, okay, and then I look at this bottom intersection, notice that angle 3 up here is on the bottom right side of that intersection, correct? Angle 7 down here is also on the bottom right side of the intersection. So therefore, angle 3 and angle 7 are corresponding angles. Okay, they are on the same side of the transversal and in corresponding positions. I also refer to these as F angles. Because they do form, an F forms corresponding angles. So, again, such as angle 3 and angle 7. Okay? And like with all these, that F can be flipped, can be turned upside down to form the angle pairs, right? So, when you are, when you run into a situation where you have two lines cut by a transversal, you're going to end up with 4 different corresponding angles, 4 different pairs of corresponding angles. And our last one, alternate exterior angles. Again, alternate for the same reason as before, they're on alternate sides of the transversal. Exterior now means that they are not between our two lines being intersected. They are now in the exterior portion, which is up top and down below. So alternate exterior angles would be like angle 1 and angle 7. And then another pair is angle 2 and angle 8. Pairs of alternate exterior angles. Sadly, there is no letter to help us describe those angles.
No.
Okay, so this angle up here and this angle down here are alternate exterior angles. Okay. Are there questions over those 4 definitions? Let's try some examples then. Taking a look over here, I would like you, with your neighbor, to answer these 2 questions. What is a pair of alternate interior angles? And what are 3 pairs of corresponding angles? Ready, set, go. So, taking a look at the first one, which is a pair of alternate interior angles? We can identify alternate interior angles by what letter? A Z. A Z. T's and Z's are not close enough. So a Z. So for example, which pair of angles?
7 and 2.
7 and 3, you could say.
2 and 6.
So angle 7 and angle 3, or angle, you're right, angle 2 and angle 6. Alternate interior angles. Excellent. How about 3 pairs of corresponding angles? Now they ask for 3 pairs, but how many pairs are there? 4. So we're just going to name all 4. So what are 3 pairs of corresponding angles? What shape or what letter can we identify these with? An F, such as which 2 angles? Angle 1 and angle 3 form an F shape. Okay. Angle 1 and angle 3. I heard angle 2 and angle 4. Angle 8 and angle 6. What's our last pair then? Angle 7 and angle 5. Any questions on identifying your different angle pairs? No. All right, your assignment for me today